Hello my dear students, this is in continuation of my previous two videos in which I have explained the properties of the polynomials as well as I have given the introduction about the basic fundamentals of the remainder theorem. So in this video I will cover remainder theorem in detail and will come to the topic of factorization of polynomials. But before coming on to that, I will just re-revise what I have told in my previous video. So you might be knowing that as it is visible on the screen also, if you divide any number 15 with 6, so 6 is called divisor, 2 is called quotient and 3 is called as the remainder, and 15 can be written as 6 into 2 plus 3, which can be written as dividend is equal to divisor into quotient plus remainder. So same thing we can apply to the polynomial also. And in the polynomial, if I take a polynomial, let's say 3x square plus x minus 1, which is a polynomial px, and if we divide it by another polynomial x plus 1, whose degree is less than or equal to the px, then if we divide it, we get a quotient 3x minus 2 and a remainder 1. So the polynomial can be written as same way, like we write the number px is called as the dividend, x plus 1 is called, which is called as gx, we call as a divisor, and 3x minus 2, which is a quotient, which we call as qx, plus rx is the remainder. So any polynomial can be expressed in the form of px is equal to gx into qx plus rx. Here we should remember that the degree of the polynomial gx will be less than or at the most equal to the degree of px and the degree of rx, because remainder will always be less than the divisor. So similarly the degree of rx will also be less than degree of gx. So if I put x is equal to minus 1, means I will try to make x plus 1 is equal to 0. So if I make divisor equal to 0, so what will happen? I will be remaining with the remainder only. So remainder only. So p of minus 1 is minus 1, which is a method by which we can find out the remainder if we divide a particular polynomial with a divisor. The example is clear here. Suppose px is equal to 3x square plus x minus 1. Same thing. If I divide this polynomial by x plus 1. So instead of doing the whole division, what we have done earlier, if I substitute the value of x is equal to minus 1 into the polynomial, the value which I get is called as the remainder. So now I will come on to the remainder theorem. So the remainder theorem says if px be any polynomial of degree greater than or equal to 1 and let a be any real number, if px be divided by a linear polynomial x minus a, then remainder is pa. So we know and we have revised just now, any polynomial px can be written as x minus a into qx, where qx is called as quotient and rx is called as the remainder. If, as explained earlier, if I put x is equal to a, so what will happen? P of a will be a minus a into qx plus ra. So pa will be ra is what we have explained. Your remainder can be obtained directly by putting the value of a into the polynomial. So whatever value we get will be the remainder if I divide the polynomial by x minus a. So you can say that x minus a will be one of the factor of the polynomial if we get the remainder as 0. So this you should remember, because we will make use of this to do the factorization of the cubic polynomials or the polynomials with a degree 3. Just for the sake of understanding, I am taking up an example or which is having a degree 3. So x to the power 3 plus 3x square plus 3x plus 1. If we divide it by x plus 1, then what is the remainder? So as I told, from the remainder theorem, I can equate x plus 1 is equal to 0, because from the remainder theorem, I can write px is equal to x plus 1 into qx plus rx, because I am dividing with the divisor x plus 1. I'll get a quotient qx and I will get a remainder. So I have to find out the value of the remainder. So I'll put x plus, I will equate x plus 1 is equal to 0. If I put this equal to 0, then the value whatever will be remaining, then whatever we will get in the value of px, that will be the remainder. So I'll put x is equal to minus 1. So p of minus 1 will be 0 into q times of minus 1 plus r. So r, the remainder, I can get by putting the value of x as minus 1 into the polynomial. I have substituted this value minus 1 in this polynomial and I got the value of r as 0. So r as 0 means, this itself means that the polynomial is divisible by x plus 1 and x plus 1 will be one of the factor of the polynomial. Now the factorization of the polynomials. Now after having understood the remainder theorem, I'll come to the factorization of the polynomial. You can see if there is any quadratic polynomial or a polynomial with a degree 2, ax square plus bx plus c, which is a standard form. Let us say that it can be factorized into two factors, that is px plus q and rx plus s. So each one is a linear polynomial. When we multiply two linear polynomials, I will get a polynomial of degree 2. So ax square plus bx plus c, I am equating it by with these factors px plus q and rx plus s. When we multiply and solve it, we will get it is prx square plus ps plus qr into x plus qs. You can solve this by a simple mathematics and a multiplication, that you will get this value. If I put PR is equal to A, if I am comparing the coefficient, PR will become A and QS will become C. These two are evident, and PS plus QR will become B. Now if you multiply PS into QR, PS into QR, which is these two numbers. If I multiply these two, I will get PR into QS. I am just rearranged. S I have brought on this side and R on this side. So PR into, which is AC. So you can see that the middle term will be the sum of the two numbers. One is the coefficient of A and one is the constant term. So the middle term will be the sum of two the coefficient of the middle term will be sum of the first and the last term. This you have to remember, because this property will be used to do the factorization. For better understanding, I have simplified it. Let us say that there is a polynomial which can be factorized into the form x minus a into x minus b. This is a more simple way of understanding, because these two are almost same, but this is a better way. X minus a into x minus b. If I factorize in two form and I multiply it, I will get a plus b. So here it is very much evident that multiplication, here the factor of x square is 1. So a into b is nothing but the multiplication of the coefficient of x square and a constant term, which is ab, and the middle term is the sum of the coefficient of x square and a constant term. So this you can very well see here. So a plus b, the middle term will be the sum of the first and the last coefficients. So middle term is the sum of the two factors. In fact, we call it factors because a and b, x minus a and x minus b are the two factors. So a and b, their summation will be the middle term. So similarly, if I take a cubic polynomial and if I multiply it, you can see that I have done the multiplication. First, I have multiplied x minus a with x minus b, and once with this multiplication, I have multiplied with x minus c. So we see that the last term is having ABC. This is also an interesting thing for to understand. See, x minus a, x minus b, x minus c. Yani a, b, c are the roots. So last three terms, so the last term, which is a constant term, will carry a, b, and c. If I multiply a into b into c, that is a, b, c. So the last term is nothing but if I factorize the last term, I will get the roots of the polynomial, and then I can factorize into x minus a, x minus b into x minus c. This is very important because I will be making use of this to do the factorization of a cubic polynomial. And the first, so I am summarizing the factorization rules. One, for a quadratic polynomial, ax square plus bx plus c. The coefficient of x is sum of the two factors of the polynomial that we have to remember. And for a cubic polynomial, if I put px is equal to 0 in a polynomial, and if I get x is equal to a, if px is equal to 0, if x is equal to a, then x minus a is one of the factor of the polynomial that we have seen in the remainder theorem. And we can write the remainder theorem in the form px is equal to x minus a into qx. Hope you would have understood these three simple rules. The second rule is constant term is the product of the possible factors, which I have explained here. The constant term is the product of the possible factor. Now, the example I am taking is a quadratic polynomial y square minus 5y plus 6. You can see the middle term will be the sum of the first and the last, that is the product of the first and the last term. If I factorize, and then if I factorize and then we do a rearrangement in such a way so that the factors will give the summation of the middle term. So 6 is equal to 1 into 2 into 3, we have factorized it, and you can see here that 2 and 3 and 1, they are all the factors. So I do the recombination. So 5 will become 2 plus 3. 2 is also a factor, 3 is also a factor of 6, and this summation is becoming 5, which is the middle term. So I have made use of this fact, and then I have substituted the value of 5 as 2 plus 3 into y plus 6, and then solved it y square minus 2y minus 3y plus 6, and then taken y as common, so y minus 2, and in the second part I have taken 3 as a common, so I will get y minus 2. So in these two terms y minus 2 is common, which I have taken, and the next term is y minus 3. So this is how we got the factorization of a quadratic polynomial. Now for a cubic polynomial, x cube minus 23x square, I am taking one more example, minus 120. Here you see I have already told that the factors of 120 are so many, 1, 2, 3, plus, minus, 5, 6, 8, 10, 15, because I have done this, I have done the factorization and possible combinations I have tried to make so that we get the maximum number of factors. So out of these two factors, any of the factor will definitely satisfy this, so that will satisfy this, and we get a first factor of this polynomial. So I am trying with first number x is equal to 1. If I am trying with x is equal to 1, because plus minus 1, in that itself I am getting the value of p1 as 0. P1 as 0 means x minus 1 will be the factor of the polynomial from the remainder theorem. So as per the remainder theorem, x minus 1 will be the factor of a polynomial. Now when I divide this with x minus 1, so what I will do here, to get the first term, I am leaving this blank. So I am putting x, and x minus 1 is one of the factors. So I have taken x minus 1. So to get x cube, I have to multiply it with x square. X minus 1 I have to multiply with x square, then only I will get x cube. So my first term is x cube. So my first term is x cube, and the second term will be minus x square when I have multiplied it. Correct? Now I have got now minus x square. So to get the polynomial, I am still remaining with 22x square, because minus 1x square I have got. I have to still arrange minus 22x square. So what I will do? I will do minus 22x. I have written, because I multiply it again by x minus 1. This I have deliberately chosen 22x, so that I get, when I multiply it, I will get 22x square, because this time I have to taken as x, because this term is x. Now I have to search for x square, not x cube. First time I have taken x square because I was looking for x cube. So now you see I have got minus x square minus 22x square, which is equal to minus 23x square. Now after having got this, now what I will choose, I have got 22x. I still have to get, and out of 142, 22x I have got. I still have to get 120x. So what I will do, I will multiply with 120 and then x minus 1. You see, if I multiply, I will get 122x minus 122. So automatically minus 120 has come. So you can see that I have done the factorization in such a way that in all the terms, that is the splitting is done in such a way so that I got x minus 1 in almost all the terms. So I have now taken x minus 1 as constant, and inside I got x square minus 22x plus 120, which is a quadratic equation. You know the quadratic equation, the middle term has to be the sum of the factors of 120. So 120, if I do it factorization, the two numbers which I can get is 12 into 10, which will give 120, and when I do the summation, I'll get 22, 12 plus 10. So I have factorization is done, minus 12 plus 10x plus 120 minus 12x minus 10x plus 120. I have splitted it, and then I have taken x as common. X minus 12 is the first number, and in the second time I have taken 10 as common. I will get x minus 12. So the factorization is x minus 12 into x minus 10. So the total factorization of this polynomial will have three linear polynomials: x minus 1, x minus 12, and x minus 10. So this is how we achieve the factorization of a cubic polynomial. So in my last video, I will cover most of the examples of quadratic and cubic polynomial and do the factorization so that you understand this. So my next video will cover the solved and the unsolved examples for understanding.